In this lesson, we're going to look at vertex form and number types. Our objective: understand what a quadratic is, understand vertex form of a quadratic, and understand number types. Vocabulary. Quadratic, equation where the largest power is 2 and it creates a parabola. So we have a power of 2 in the problem, and that's the biggest exponent there is. Vertex, turning point of a graph. Radical expression, solutions with square roots. Irrational number, number that can't be written as a fraction. The first thing we want to look at is what exactly is a quadratic. Well, a quadratic, we're going to look at two basic equation types that can be written. Here's our first one. Notice we have a power of 2 focused on the x. Yes, it has a plus 3 in there, but the x has a power of 2 with this here. So this would be a quadratic. Largest power is 2, and it's with the variable x. Here we have multiple x's, but the largest one has a power of 2 with it, so that would be a quadratic also. The graphs look like these. They're kind of a U shape. It's called a parabola. The U could go down or it could go up. The vertex is basically right in the middle here, and on either side we have mirror images. So these are the vertices. Vertex form looks like this: y equals a, parentheses x minus h, and the parentheses squared, plus k. One thing that you need to know about this is a is a coefficient. We'll look at that more in another chapter. So most of the time we'll just be given a, or we'll find a, but we won't really focus on what it's saying. We'll just use it. H and K are known as the vertex. Okay, and notice how H is always being subtracted, so it's really the opposite of what it says. So subtracting a negative would turn that positive. Subtracting a positive keeps it negative. K, because it's addition, is always straightforward. So if it's a negative K, this would really be subtraction. If it's positive, it would be a plus sign. So here I have vertex form. I want to kind of identify the parts of it. In this one, I have the parts, and we want to create vertex form. So our a value is 3. It's what's being multiplied out here. Okay. Our vertex, well, this is negative 4, but h is always the opposite. So instead of negative 4, our vertex is actually positive 4. And then we have a positive 5 here. So notice how this 4 and this 4 don't match up. This is a negative 4, this is a positive 4. It's always opposite in that situation, whereas this positive 5 and this plus 5 are the same. Now let's look at, if we're given these things, how we create vertex form. So we're going to have y equals, a value is negative 1. We're going to have x. It's always subtraction, and our x value is negative 2, so we're going to minus 2. So we've got x minus negative 2 squared, and then we've got minus 1. This is always going to be plus negative 1 there. And now we're just going to simplify it a little. So y equals negative 1. Instead of x minus negative 2, we can write that as x plus 2. And instead of adding a negative 1, we can just write minus 1. Alright, the last thing that we want to look at are our number types. So what you'll need to do is kind of create this figure, and I'm going to go through the different types of numbers and what are some examples of those types. The main thing here is this big rectangle is known as the real number system. So everything inside here is a real number. Okay? What we start with is this small box here. It's our most basic numbers. They're known as our counting numbers. Sometimes they're called natural numbers. They're what we count by. 1, 2, 3, and so on. Okay? Whole numbers include the counting numbers. That's why it boxes around it. And these whole numbers are all the counting numbers plus 0. So it's 0, 1, 2, 3, 4, and so on. Those are our whole numbers. Integers, again, include the whole and counting numbers. They're included in that. But they also add into it all the negative counting numbers. So we've also got to include -1, -2, -3, and so on. So the integers would be -1, -2, -3, -4, -5, and 0, and 1, 2, 3, 4, like that. Our rational numbers, again, include all of these squares, but rational numbers are any number that can be turned into a fraction. The word ratio is in it, and ratio is a fraction. So any fraction or any decimal that can be written as a fraction is rational, such as 3.5, -1.47, 1/4, 2 and -2 and 1/5, -4.3 repeating. So basically anything that can be written as a fraction. These are all possibilities. These are all kind of grouped together. That's why I used red. I'm not going to use blue because irrational numbers are their own separate thing. Irrational numbers are numbers that can't be written as a fraction. A lot of these are square roots that don't come out perfect. So the square root of 2 doesn't come out perfect, so it's irrational. Goes on forever. We've got symbols like pi. Pi isn't 3.14, it's 3.14, and then there's a bunch of numbers after that. It never stops. Irrational numbers are basically any square root that doesn't come out perfect. So the square root of 4 is not irrational because the square root of 4 is 2. The square root of 2, that one's kind of weird. We also have something called rational expressions, which are things like the square root of 3 plus 7. What this is even though 7 is rational, square root of 3 isn't, and an irrational plus a rational will always give us an irrational. Alright, if there's any part of this that you didn't understand or you need to watch again, please pause, rewind, and rewatch the video, and bring any questions to class. Thank you.